Processes affecting the composition of the early atmosphere. The material from which the solar system formed is often described as a gas cloud or, at a later stage, a solar nebula. The cloud was rich in volatiles termed primordial gases and must have been the ultimate source of the atoms in the present atmosphere. What is of primary concern, however, is the sequence of events and processes by which the volatiles present in the initial gas cloud were transferred to Earth's inventory and the efficiency with which this was accomplished. The formation of the solar system began when one portion of the gas cloud became dense enough due to compression by some external force, a shock wave, from the explosion of a nearby supernova, perhaps to gravitationally attract the material around it. This material fell into the region of higher density, making it even denser and attracting other material from still further away. As gravitational collapse continued, the center of the cloud became very dense and hot. Because the kinetic energy of the incoming material was released as heat, thermonuclear reactions began at the core of the central object, the Sun. Capture and retention of primordial gas. Far from the central point, the material in the gas cloud tended to settle to an extensive equatorial plain around the Sun. As the material in this disk cooled, chunks of rock grew and accreted to form the planets. The planets are much less massive than the Sun, but if they grew large enough and if the gases around them were cool enough, they could accumulate an atmosphere from the volatile components of the gas cloud. A planetary atmosphere accumulated in this way would consist of primordial gases, that the relative abundances of the individual components would differ from those in the gas cloud. If the gravitational field of the new planet were strong enough to hold some, but not all, of the gases around it, it is convenient to express the strength of a gravitational field in terms of escape velocity, the speed at which any particle, a molecule, or spacecraft must be traveling in order to overcome the force of gravity. For Earth, this velocity is 11.3 kilometers, 7.0 miles per second. And it follows that, once the solid material had accumulated, gas molecules passing Earth at lower speeds would have been captured and accumulated to form an atmosphere. The speed at which a gas molecule moves is proportional to T, m1/2, where T is absolute temperature in kelvins, K and m is molecular mass. The uppermost layers of the present atmosphere are still very hot and might have been much hotter early in Earth's history. At temperatures below 2000 K, however, molecules of any compound with a molecular weight greater than about 10 will have an average velocity of less than 11.3 kilometers per second, 7.0 miles per second. On this basis, it has long been thought that Earth's earliest atmosphere must have been a mixture of the primordial gases with molecular weights greater than 10.